Well, I'm very excited to be here today. I'm very thankful to Ida for having us and for putting me last because it means I get to take as long as I want, right? So they always say to begin your talk with something that the entire audience can relate to. I think the best way to pose this is by using the Apple versus Android debate. Personally, I'm an iPhone user, and I know by admitting that I've probably lost half the audience already, so I'm sorry. My advisor, Dr. Thomas, is an Android user though. Even though we're on different sides of this debate, we're still able to communicate, still able to collaborate. I see the green bubbles come up with her, and it doesn't really matter to me, but this is a story of West Point being on one side of the debate, and Tradoc, our client, being on the other side of the debate. And through the tools I know as a student of the math department and as a data scientist, I've tried to solve this problem using very simple statistical techniques. So a little bit of background. Body shape is a way of measuring the body, and it doesn't involve scales, doesn't involve tape measures. It involves two things, and that's anthropomorphic dimensions and unsupervised learning. And so in a subsample of 239 West Point cadets, we detected that there were 5 robust body shapes in this sample, and it's really just the k-means clusters. And these are examples taken from each of those clusters. And that was done in research last year by a graduate of West Point, who's now a second lieutenant. Her name is Charlotte Spencer. And so initially my thought was, well, if we increase n, we should be able to detect more body shapes, and thereby we will be able to better classify people into these body shapes. And the whole point of it is to make a more inclusive and more a modernized body standard for all soldiers in the U.S. Army. That's a study that's being done now at Fort Lee. It was done at Fort Bragg in early 2021. And this graph in the bottom left is from a different study done in Germany. They had a data set size 10,000, and they broke the data set down a few times, and they show the hypothesis that I have posed, which is that if we increase n, we should be able to detect more body shapes. But the problem is, of course, time is limited, and this is a one-year capstone project, and so we couldn't exactly collect scans from all 4,000 West Point cadets. Cadets are very busy, I can attest to that, and we couldn't just expand it to 10,000 people and bring them into the lab for scanning. So what we did was we tried to discover latent data, and latent data is just data that's sitting around in repositories that is collected for other reasons. So any military member that goes to basic training or basic military training now is scanned using a 3D scanner, and that's for the purposes of uniform fitting. There's no tailors anymore. That started during the COVID pandemic, and it's continued on because it's just so efficient. So those two of those data sets, the very large ones from Lackland Air Force Base and then from Fort Jackson in South Carolina, are both initial recruits taken at their uniform fitting in basic military training. We took a data set from the University of Hawaii that was part of just an obesity study that they're doing there called Shape Up Adult. And then there's one taken from Pennington Biomedical Research Laboratory in Baton Rouge, Louisiana. And that's unique because it involves a small group of 100 people across age ranges, and they are scanned in 3 commercially available 3D scanners, which you can see on the slide here. This gets to the Apple versus Android debate that I was referring to in my first slide. All 3 of these scanners are created by different corporations. They all have proprietary algorithms. They're all used for different purposes. They all cost, well, I guess the Fit3D and the Human Solution scanners cost the same amount of money, but they've all got proprietary algorithms. And it's a shortcut we take in our mind. We think, when we think about a 3D scanner, we think that no matter which scanner it is, the same person that's standing on the scanner is going to have the same measurement for all for all parts of their body. And the truth of the matter is that's incorrect for a variety of reasons. But the easiest way I can explain is that if I asked everyone in the room to just point at their calf muscle, probably everyone would point at their leg, everyone would probably point at the point below their knee, probably everyone would go to the back of their leg, but the exact point where your finger touches your body would be just slightly different from your neighbor. And 3D scanners are the exact same way. So if one, maybe the Psyche defines it as the calf to be measured at the midpoint between the lower thigh and the ankle, whereas Fit3D might define it to be at the midpoint between the kneecap and the floor. And then the question becomes, well, where's the kneecap? Where's the lower thigh? It becomes different, and you can kind of see an example here. So these are all pictures taken from the 3D scanners manuals, and it defines where each of the measurements is taken. In this case, they're measuring waist circumference. So waist circumference is one of the current measurements taken for the Army's body composition program. And each of these scanners, as you can see, takes it in a slightly different place, but it's easier to see if you look at these plots right here. So this is taken using the special data set that I referred to from Pennington Biomedical Research Laboratory. Again, all 100 people were scanned on the 3 different 3D scanners. And you can see, because these points don't exactly follow the y=x line, that indicates that the measurements are not exactly the same from each of the 3D scanners. And so we used simple linear regression, the easiest and most fundamental statistical tool in the books. And we created a map that would map between all 3 of these 3D scanners. So if I took measurements from the Psyche data and I wanted to get to human solutions, I could go through Fit3D and then translate to human solutions. And so this process was taken for all 13 of the measurements. Those 13 measurements are the ones that are shared between the 3 3D scanners. So for example, the neck circumference, as you can see, Psyche overestimates the human solutions measurement a little bit. The Fit3D overestimates the human solutions a little bit. And the standard scale we chose was the human solutions scale. And that's because we were told by one of our advisors that that was the industry standard. And lastly, once we had transformed all of the data sets into a standard scale, we performed k-means clustering, and we found that contrary to what we had believed would happen, the elbow stays right about 5 clusters. And so it turns out that maybe as you increase n, the number of clusters doesn't exactly change. So thank you again to IDA for having us. And like I said, like everyone has said, my poster will be in the lobby. So